This is a vacuum, and this is a balloon.
And it's a balloon man.
Balloon man, yeah, you can see that little face on it. I thought you were over there with it. You can see that face on it that someone drew.
So why is the balloon man sad right now? Why is he not at full power? So like, why is he so small right now? Does anybody know that?
Because he's deflated.
He is deflated.
And that's the constant pressure that's
yeah,
in the
so someone blew
environment
him
right now.
up and did a horrible job at it and didn't make him very happy. And so now he's just sitting around and he's actually just not going to get any better here. And he's also like us right now. He's under a lot of pressure. So he hates being here in this environment at school and on this planet even, you could say. So what's happening right now is he's deflated, and it's because he's under all the pressure of the oxygen above us and the air above us. And that keeps him from filling up. But what happens if you get stress relief, right? What happens if you get into another pressured environment? And that's what this is for. It's a vacuum, and it's a vacuum chamber. So the vacuum will pull the pressure from the earth away from him. It's like spa day. Do you mind starting it?
Where's the start? It should be. Okay, that one says oil. Don't do that one.
It was at a weird spot.
Do you know where it is, Holly?
Where what is?
The on button for this. It was placed at a weird spot. It's right next to the cable.
Okay, so as the pressure drops, what do you think will happen to the balloon? Hopefully it's not like...
No, I just keep setting to it. Let me see all the second.
There we go.
Whoa.
Good job,
Whoa.
Troy.
Whoa.
He has good tape skills.
Yeah.
So as you see, the balloon man,
Balloon
what
man.
I call it, is expanding because it has to find equilibrium with the pressure.
Right, so this is like a temperature thing, right? So there's a bunch of like air molecules inside there, and they're moving around. And the thing about anything in temperature equilibrium is it wants to be equal everywhere, right? So when you have a really high density outside of it, the air inside the balloon, everything outside of it wants to get in the balloon because it wants to move to where there's less density, where it can fit into that state. Whenever you draw a vacuum, now this guy is really embiggered because he's surrounded by a bunch of chumps. And all of those chumps want what he's got. So he's expanding outwards because the air inside of him is trying to get to a less energetic state. Right now it's really energetic because it's trapped and it wants to get to a larger volume where it doesn't have to be trapped in there. And then the sad relief of a bad seal. And that's what happened after the 2-week break.
It wasn't a break.
It wasn't a break for
You're right. All right, we're gonna do the same thing again with the Marshmallow Man, but this one's kind of interesting because
Yeah.
he acts a little differently.
And so the balloon has like a stretchy surface. It's very elastic and it won't really pop in a sense. So that's what we need to be looking for in these marshmallows because it's not the same material as a balloon.
And so why is the marshmallow puffy? Does anybody know why a marshmallow is so like happy and gooey and chewy, but also like so not dense? Does anybody know why? And the manufacturing of it? So they pull it full of air. Like it's like the sugary stuff. It's basically corn syrup now, and then they just puff it full of air, and that's why it gets to be so big. And that's why like if you ever like press down on it, it'll like be springy and things like that. It's a bunch of pockets of air. So we're gonna see what happens with these pockets of air whenever we pull the vacuum. Alright, so it's starting to hit.
Yeah, a little bit.
It'll take a little while with the big ones. But if you guys can see it, it's starting to wrinkle up a little bit. Like, this guy's getting old. So spa day does not work for him. It's just reminding him of his impinging age. Sorry, it's really wrinkly there, but you can start to see it happening in the edge. And it's starting to piece it together more and more. So with the balloon, it changed its size and it went back to its size. Is there any reason to believe that this isn't what's going to happen with the marshmallow?
On this side,
Is it still cloudy?
well, no, like you're over here.
So with the marshmallows, do we think that the marshmallows are going to return to their original size whenever they're put under the same pressure? Thank you. Ah, there it goes.
Interesting.
Look at how big it's getting.
And you'll have to look closely right here.
Thanks, Seth. See how fat it's getting? It's just the joy of life, right?
Do y'all think it'll just continuously get bigger and bigger?
It's a Pressure 15.
It is. So whenever we remove the vacuum, will it return down to its normal size? I want to hear bets. Francisco, what do you think is going to happen? No. Okay. Do you think it's going to stay big like this?
I think it's gonna stay big like that. Or it might shrink a little bit, but that's not gonna go down.
You think it's going to stay like this? Okay, so far the only consensus is that it's going to not go back down. And do you think that's because like the structure inside just isn't going to change? Like there's no reason for it to return? All right, well let's get the vacuum and see what happens. Oh, it's getting smaller. Oh no. This is the weight loss this is keto.
Keto.
Oh no. And it's a little bit harder to see with the bigger marshmallows, but it's actually smaller than it originally was.
Well, you can see that it's like more wrinkly.
Wrinkly everywhere.
Yeah.
So it's actually doing the opposite of what you think.
So this is a normal marshmallow, and this is one of the wrinkly,
Gross.
gross ones.
Old. So does anybody know why this happens? Why it doesn't just do what the balloon does? Seth, do you want to tell them?
Yeah. So the air was drawn out of the marshmallows. So now it's like it basically like did what the balloon couldn't, and it met equilibrium inside the vacuum. So now it's trying to still adjust to the vacuum right now, and the air molecules can't really go back in because of just how the marshmallow is made with the polymer and the non-crystalline substance that it's made of. So it can't like fix itself to our pressure and our temperature like it used to.
It's like a permanent damage thing, right?
Yeah.
So like where the balloon was this rubber, which is a lot more like robust,
Oh.
and it can expand and yeah, that's sad. Can expand and contract and change its pressure. This case, the way the marshmallows are made, like you said, with polymers, once it's broken down, it's broken down. And also like there's the temperature thing too. Like these things are flowing, and whenever you have a temperature change, you're gonna have some damage done just from it flowing through, like the oxygen flowing through. It has an energy it wants to escape with, and an energy it wants to return with. All right, so I think that's all of this one, unless you have
Yeah,
anything else to say about it. Okay.